So if you ever used AI and sometimes feel like, hey, this is actually just slowing me down, there is a research paper published by Meter, which I guess is a research company that has worked with Anthropic and OpenAI to kind of evaluate various AI models and whatnot. They have this paper where they basically asked 16 different pretty senior developers. I think they said they have over 10 years of experience who have been working on large scale open source projects that have at least 1 million lines of code. And they asked them to use AI to solve some tasks, and then some other tasks they said do not use AI for, and they kind of compared the results. And it turns out that it takes them 19% longer if they use AI, which I find is a pretty interesting perspective on the use of AI in your productivity. I know I've used AI a lot on my side projects and on this channel, and I would say without a doubt it's made me a lot more productive. But at work, I do work on a project that's about 500,000 lines of code, almost 500,000 lines of code. And I don't reach for AI as much because AI tool is just not able to index your entire code base as well as a smaller project. And also, as a project grows larger, it's more complex. It feels like it's more spaghetti. And I don't think AI can really reason about this model depends on this model, but in this various random scenario, you can't do this. So you have to have more domain knowledge over your code base to be productive. And often I find that AI just doesn't help you out as much. So there's a decent amount of talking points on this article. I'm not going to dive into all of them. If you want to go check it out, I'll leave a link in the description below. But the overall idea is that they had 16 developers with moderate AI experience, and they had to complete 246 tasks. I think each task was around like a 2-hour estimate of how long it should take. They all have an average of 5 years of prior experience on the complex projects that they're working on. So they all had like open source projects that were pretty complex. And they asked them to basically do your normal workflow, but solve these tasks in a very specific way. We can monitor them. I think they also did screen recording and labeled the various parts of their workflow so they can figure out where did AI speed them up, where did AI potentially slow them down. Now, the reason studies like this is important is because there is a lot of hype with AI. And I do think AI does make developers more productive if you know how to use it properly. So let's look at this table. This x-axis, economics expert forecast. They're basically saying the economics predict that AI will make you finish work twice as fast. And a lot of these experts predict that AI will speed you up in various ways. So machine learning experts forecast that they will speed you up around like 39%. And then the people who are taking this test, even they thought that using AI would speed them up around like 23 or 24%. And even after they did the study, these same participants who are, these 16 developers, they still thought that they were more productive using AI. But in reality, after doing the study and kind of looking at the time and how long it took them to do the tasks, the researchers saw that it was almost a 20% slowdown. So everyone believes AI will make you much faster, but these results for this study, assuming that the study isn't flawed, showed a 20% decrease in productivity and speed. That's pretty crazy because I do think a lot of people hype up AI, and a lot of the studies out there aren't really focused on real life workflows. And this is one study that I think did something a little bit better, right? They actually focused on seeing open source maintainers who have a lot of experience working on tasks that they would work on anyway on their open source project, and kind of figured out, okay, if you use AI versus not, how much longer or faster does it take you? Okay, so the motivation section, this is basically saying why they are doing this research. I'm going to skip over that because we all know it's kind of important. All right, scrolling down to methodology, let's actually read this. To direct measure the real-world impact of AI tools on software development, we recruited 16 experienced developers from a large open-source repositories averaging 22,000 stars and 1 million lines of code. So that's a pretty big code base, in my opinion, right? That they've contributed to for multiple years. So not only is it a large code base, they have intellectual control over that code base. Like, they know how it kind of works. They're very intimate with the system. Developers provide lists of real issues, 246 total, that would be valuable to the repository, bug fixes, features, refactors that would normally be part of their regular work. Then we randomly assign each issue to either allow or disallow AI while working on the issue. When AI is allowed, developers can use any tool of their choice, primarily Cursor Pro with Claude 3.5 or 3.7 Sonnet. So now, granted, they're using Claude 3.5, 3.7, which I think is pretty good. If I go to Cursor, I think we're up to Claude 4 now, which I think is a little bit better than Claude 3.5. So I would say as better models come out, they should probably redo this study to see if the model is basically causing this potential slowdown. when disallowed, they work without generative AI assistance. Developers complete these tasks, which average 2 hours each while recording their screens, then self-report the total implementation time they needed. We pay developers $150 an hour as compensation for their participation in this study. Now, this one kind of stood out to me. Like, if you're getting paid a bunch of money to do a study, there may be some type of inverse incentive to like work slower so you get paid more. They do say that they don't think that's the case, and they do talk about that in this study. And I will say, I literally loaded this up with AI. Chat PDF is a pretty cool thing. You can load up a PDF and then chat over it. And I asked a lot of questions. Like, I really challenged like their way they did the studies. And it seems like they thought about, these different things of like, okay, what could potentially skew these study results? So scrolling down, it's a little chart that kind of shows you how they work. Basically, they have some tasks. They told the developers to estimate how long they think it would take with and without AI. And then they basically took some tasks and allowed the developers to use the AI. Other tasks they disallowed. They monitored how long it took them to do it. And then they basically, got the results of the survey. I'm not going to read through that. Core results. So the core results is when developers are allowed to use AI tools, they take 90% longer to complete issues, a significant slowdown that goes against developer beliefs and expert forecasts. This gap between perception and reality is striking. Developers expect AI to speed them up 24%, and even after experiencing the slowdown, they still believe AI have sped them up. So even though developers are actually performing worse and slower, they think, like there's a psychological thing that they think AI makes them faster, right? And I don't know if it's because they're not doing as much typing or they don't have to do as much thinking, and you have this other thing that's doing all the thinking for you. So you perceive that you're not actually working slower, but in fact you really are. Now, I think this is just a quick summary of the research. I think going to the actual research paper, which I tried to read through this as much as possible, they have some pretty cool charts and graphs on here that kind of explain more of how the process worked and some of the things they measured. So like one of the important thing is they did screen recording and watched the developers do their coding, right? So the average percentage of time spent per activity among labeled screen recordings. Turns out when you're using AI, you actually spend a bunch more time reviewing the AI output, right? And this is something we all know. When you use Claude and Cursor and all these AI tools, a lot of the time it hallucinates and gives you out-of-date code. It gives you code that just doesn't work, or it just deletes code randomly from your code base, right? And so you have to spend more time reviewing all this code to make sure it didn't inject a bunch of security issues or add in a bunch of bugs or basically break your application. Now, I will say that as you get better at prompting, you get better results. And as the models improve over time, you also get better results. And I found that at least working on little side projects, you don't have to review the code as much. Like if you can prompt very well, oftentimes the code just works. And maybe it takes you one more reprompt to like make it more performant or make it more secure, etc. Now, another activity they monitored, which uses up a lot of time, is prompting. Before, you didn't have the prompt AI. Now you actually have to think of a prompt. You have to either type it in or use some type of voice to text to translate it into your prompt text window. And that eats up your time too. So thinking about a good prompt can be very challenging for some people. Like some people don't know how to communicate their ideas. And if you're bad at communicating your thoughts onto paper, and then having the prompt generate bad code, you will probably get stuck on this area of like writing a bad prompt, getting bad results, reprompting, still getting bad results, waiting on AI to finish, which can take 10 to 20 to 30 seconds depending on the model. And so I think this potentially could eat up a lot of time. And I think as AI gets better and maybe reduces in latency and becomes very fast at generating results, I think this will go down. Prompting AI is a skill issue in my opinion. It does take a lot of effort to learn how to properly prompt for not only your own code base, but like whatever tech stack you're using, knowing when you think AI is going to mess up. But some other things to point out, active coding, as you can tell, the coding time drops significantly, right? That's almost, we went from like 37% all the way down to 23%. So that's a decent decrease in coding activity. So it's almost like we took some of the activities over here, the reading and searching. So now you don't have to go to Google and like read through GitHub issues and keep scrolling through a bunch of comments. A lot of that stuff has been augmented and probably eats up time over here, right? Testing and debugging. I would say that AI does help with this. Sometimes you can just paste an error in your code base directly into the prompt and it just fixes the error for you. So that can sometimes reduce the amount of times that you're spent testing and debugging and trying to read through error codes. Get an environment. Yeah, I wouldn't think that this would change much. Idle and overhead. This one I'm not really sure about. This one, you would think that it's them waiting on the AI to give a response, but they have that over here labeled. So what is idle and overhead? I'm not really sure. Maybe it's just them trying to spend extra time thinking about what's going on. Because I will say when you're using AI, you're basically offloading your thought process. You're letting someone else think for you. And then when all the code is just dumped into your code base, you probably have to spend a lot more time reviewing the AI. But that's also labeled over here. So I'm not really sure what idle overhead is. Let me actually ask, what is considered idle overhead in this study? In this study, the idle is referring to periods that the developers are not actively engaged in coding or searching for information, but are still interacting with AI tools or waiting for AI output. Specifically, when developers have access to AI assistants, they spend larger portions of their time waiting for AI outputs, prompting the AI system, waiting for AI generation, or simply idle without significant activity visible on the screen recording. So yeah, this is just them like sitting around doing nothing. I don't know why that happens more when you're using Cursor or AI tools, but I'm guessing you have to spend a lot of time reading. And they probably weren't using eye tracking on this research paper. Maybe they were. So how would you know someone's reading versus like what? I think they're just tracking like mouse movements to see if they're engaging with the computer. So I would think that this aligns with how I have dealt with AI. Like when you use Cursor, you spend less time coding and more time like reviewing and waiting for AI and prompting, okay? So I think that's pretty cool. Now, one thing I want to point out that's important about this study is that they did recommend using Cursor Pro, and they did give people a subscription for Cursor Pro. But if you read this, it says that 93% had prior experience with tools like ChatGPT, but only 44% had experience with Cursor. And I think this is important to point out because using Cursor and understanding how to use these agentic tools to become more productive, it's not something you just learn overnight, right? You have to get familiar with what tooling is going to help you solve the particular problem that you're doing. If you're doing a bug fix, maybe you want to use agentic, maybe you want to use, tab completion, maybe you want to do a whole code index and search over it and ask questions about your code base to try to fix the issue. So unless you have like very intimate experience with Cursor or using Claude Code or whatever other tooling, just using ChatGPT, like that's not going to translate very well to be productive using Cursor. So I know they said the participants can use whatever AI tool that they want, but I will say that unless you are actively trying to use AI and getting good at when you can use it and not, it's going to slow you down. That's what I've seen myself when AI and Cursor first came out. I felt like I got slowed down a little bit, but then as you get into the flow of things, like it can really speed you up from my perspective, at least on smaller projects, not necessarily a million line code based projects. Another thing I want to point out is that when using AI, the participants often use Cursor IDE, which sometimes differs from their normal development experience, and they put NeoVim and PyCharm. This is something else that I think is very important to talk about. If you are familiar with NeoVim and you've been coding with NeoVim for 10 years, and they ask you to try to use Cursor IDE, you are going to see a slowdown in your productivity. Like, I don't care what you argue, there's no way you can switch from NeoVim to VS Code or Cursor and still be as productive as you once were with NeoVim. There's a bunch of other shortcuts or different hotkeys. I know there's like a Vim plugin with VS Code, but still, I think it's just, there's a difference enough with the IDE that it's going to slow you down. And I'm guessing at the time, Claude Code wasn't even out. So like this was back in January of 2025. So I don't know if Claude Code was out. So a lot of the NeoVim users, I don't know what they're using. Hopefully they have some plugins that work kind of like Cursor. But I would be curious to see like which users were heavy NeoVim users and then they were using Cursor during this study time period, because that could significantly slow them down. The researchers do state that they don't think that the difference in the editor was an issue. Developers reported that they were not significantly inconvenienced or affected by the differences compared to their normal workflows, right? But we all know how optimistic developers are with, yeah, this didn't slow me down, but now you're 20% slower, right? Or yeah, that story will only take one day and then they spend 2 weeks trying to solve that user story. So I don't think developers are very good at understanding when something is making them super slow or when they're wasting a bunch of time on something, which we see all the time with like agile development, story pointing, like estimates. People are just very bad at estimating the reality of the situation. Now, by the way, if you don't know how research papers works, basically when you write a research paper, you try to reference other people's research, right? So it's not just your paper alone, it's your paper comparing against various other studies that have been made in the same topic. So I would read through the references. There's a bunch of other research papers that are related. And so if you want to like take what you learned here and like go and read about these other papers, there's 42 different links you could kind of read through if you're that type of person. But I'm not going to spend my time reading all those research papers. So let's kind of scroll down. All right, so here's a graph. Basically, it's taking the person's prior experience with Copilot or with Cursor and trying to see how much did they slow down or speed up. By the way, the lower you get on this, the slower they were finishing the tasks. The higher up on this, the y-axis, the faster they got. So the two outliers that are worth looking at is this one and this one, okay? So Cursor was a primary IDE before the experiment. There were 3 devs out of the pool who said that they use Cursor as a primary IDE. Now, the curious thing is that the range of the productivity went up to 20% faster. So there was a developer, maybe one, who actually finished their tasks 20% faster. Now, it could be that they already were slowed down by AI. They've been using Cursor for so long that they're just slow at coding now. And so when they took away the AI and told them to solve tasks, they just basically couldn't solve them, right? So that is a possibility. And there's been studies that show that the more you use AI, the less you are able to problem solve and the slower your brain gets. And like it does cause atrophy in your problem solving skills. So I kind of asked questions about that one. Over here, no web LLM experience. So here's another interesting one. If you had no experience using LLMs before, some of their tasks, again, this line is their tasks. So some of the tasks they were able to knock out almost 25% faster than their normal tasks. But then again, a lot of these tasks down here, they were 120% slower. Okay, so not having LLM experience and then being asked to use AI on some tasks, I think shows that there is a learning curve. Like it does take time to understand prompting. It takes time to understand how to read the output of AI. It takes time to understand how to even use Cursor as a tool. So for me looking at this makes sense, right? If you have absolutely no experience with AI and then you're asked to do a research study and they ask you to use AI for some task or Cursor or Claude or whatever, yes, you're going to get faster in some cases and you're going to get super slow in some cases. So I do think having prior experience with AI is important, but they also state down below, there's another graph where they don't think having prior AI experience is enough to slow you down because they basically took their participants and then they started excluding how long it took to do the first AI issue. And then they started excluding the first 2 AI issues. So this is basically saying that, okay, what if there is a learning curve to using AI? Okay, and what they notice is that even if they started excluding the first couple of tasks that they asked them to use AI with, they still got slower, right? So you'd think that as you start using AI more, these tasks would, go up, and then at some point you would become productive. But they saw that even if they excluded the first 6 or 7 AI issues, they still got slower, which I think is pretty interesting, right? This kind of shows that even if there's a learning curve with an LLM in Cursor, that it doesn't matter. Like they still became 20% slower, which kind of contradicts what I was just talking about here, like no web LLM experience. But from my perspective, right? Again, this is a study of 16 developers. I'm the 17th developer. I have found that it does take a learning curve. And I don't think solving, 6 or 7 bug fixes is enough to really ramp up with how to use Cursor properly or AI prompting properly. Here is another interesting one. So change in time when AI is allowed. And then basically this down here, the x-axis is how much time they've spent with AI, right? So we don't see large differences across the first 50 hours that developers are using Cursor, but past 50 hours, we observe positive speed up. So there's something to say that if you've been using Cursor for 50 hours or more, for some reason you are faster at doing the AI work. And again, is this because you're just actually, your baseline has been dumbed down, like you're now just bad at coding? And so when they take away Cursor from you and ask you to do these tasks with no AI, of course you're going to be faster with AI, right? So this could be that type of phenomena. This is skewing the results because these people are already so ingrained with using Cursor and AI that their baseline is just bad, right? They're just not productive anymore. I'd be curious about asking that. Again, I'm not a researcher. I don't even know how to read some of this stuff. Like they have some pretty intense like math formulas here, like statistical analysis and stuff. I don't know that stuff. I'm just reading through the charts and reading these little figures and then trying to break them down to you all who are watching me. These are like factors that they really think might have slowed down developers. For example, high developer familiarity with repositories, right? So developers slow down more on issues they are familiar with, which could make sense, right? If you know a certain way and a certain process of solving bugs, and then all of a sudden you're given a different requirement of how you solve them, that's going to slow you down. Developers report that their experience makes it difficult for AI to help them. Okay, and this is probably because AI often hallucinates and gives you bad results. So when you're already intimate with the code base and then AI is just churning out bad results and bad suggestions for you, yeah, that's probably going to slow you down. Developers average 5 years experience in 1,500 commits on the repositories. This one's another one, large and complex repositories. Developers report AI performs worse in large and complex environments. I 100% agree. I've tried using AI on a project at work, and it just doesn't perform as well as it does on like a smaller side project or like a small startup company, right? The larger the code, I think the worst AI is at understanding the complexities of how it all kind of ties together. The repository is averaging 10 years old with 1 million lines of code. So that's kind of the repositories they used. Low AI reliability. Developers accept 44% of AI generation. So that's a very low acceptance rate. So these very experienced developers on a large complex code base are not accepting most of the AI generations because it's just generating bad code. So until we can get this number up higher, I think AI is still just going to make us less productive in this particular scenario. Majority reports making major changes to clean up AI code. So a lot of times they have to go through and remove magic numbers and refactor code because AI basically just copy, paste, slop into your code base. And then you have to go and reprompt it and tell it to refactor it and clean it up. Unless you're good at prompting from the get-go. 9% of time reviewing and cleaning AI outputs. I do agree with that. I mean, you are going to have to read through code, right? Basically, you're doing PR reviews constantly as the AI generates code. And then they have this table over here, factors with unclear effects on slowdowns. Experimentally driven overuse of AIs. Developers sometimes report overuse due to experiments. So again, this whole table are things that could potentially have slowed them down. And it's a pretty big table, a lot of rows, and they're saying it's unclear. They don't really know if these things slowed them down or not. But basically, yeah, if you're put into an experiment and they're recording your screen and they're paying you per hour, there's so many different variables that could affect the psychology of you getting work done, especially if you know that you're being like screen recorded. That I don't know why, but when someone's watching you, whether it's on a live call or like your screen getting recorded, there's some psychological thing where like you just stop working well. Like, I don't know why. Like, I'm sure you've seen that at work where like everything's working fine, you're talking fine, and then someone asks you to share your screen and code, and then like it's almost like you've forgotten how to type. I don't know what it is. Someone can leave a comment if they know what the actual psychological thing is for that. Probably just something like observation anxiety or something. Developers report issues are standard but on shorter side. Unrepresented task distribution excludes non-programming tasks developers complete in normal work. I don't really know what that one was. AI increasing issue scope. Developers who reported scope creep see less slowdown. Developers who report scope creep see less slowdown. I don't know what that means. Mixed developers report on AI impact on score. All right, this one, 40% more lines of code per forecasted hour in AI allowed issues. Is that meaning that AI is basically making them write more code even though they might not need it? Or, yeah, I'm not really sure about some of this stuff. Trading speed for ease. Some developers report using AI is less effortful. High developer retention on Cursor. Low quality initial pull requests, minor differences in mean post review times between conditions, qualitative similar PR quality between conditions. I don't know. I don't think I'm smart enough to really understand this chart, but I think the idea is that the researchers thought about different things that could potentially cause people to slow down with their work, and they listed them out on these tables. And then they basically highlighted these tables to say like, hey, these things are things we thought about, but we don't think that they are slowing down the participants. For example, cheating or underuse of AI. AI used in all but 16% of allowed cases with labeled screen recordings. Only 3 cheating instances in 54 screen recordings. So I guess I remember reading the article, and what they said they did is that like if they saw people using AI on tasks they weren't supposed to do, they would consider that cheating, and they would basically filter out that task from the results. Or if they reported that a task took them 2 hours, and then they go back and watch the screen recording and actually took them 3 hours, that was something else they filtered out. I think that was like a 15 or 20% threshold where like if you misreported your time and then they watched the video and it took you actually longer or shorter, that was just a result that got filtered out. All right, that's all for the article. I want to say, leave a comment below if you think AI slows you down up to almost 20% like they're saying in the study. I would say that my results for smaller projects, AI has made me very productive, right? And maybe this is just a personal feeling, and I'm falling victim to the same thing that they saw in the study where developers would say that AI makes them faster. Even after using AI, they argue that it made them faster, but in reality, when you look at the metrics, it made them slower. But literally, like, I have made so many coding tutorials on my YouTube channel. And to build something simple in like a 6-hour video, I'm noticing that I can build these same things in like an hour or two now by using Cursor and just prompting it to generate code and modals and client-side validation. Like, there's a lot less code that I have to write and think about. And I have found huge performance gains, productivity gains using it. Now, for larger projects, I do agree that it's a lot different, right? There's a lot more that comes into a larger project. There's just more code, more complexity, and I don't think AI is able to truly understand it unless you get good at prompting and giving AI prompts specific context to where it needs to update code and how code kind of works. So those are my opinions on it. But yeah, I guess let me know what your opinions are on using AI. Do you think it makes you more productive or does it slow you down? Other than that, have a good day. Happy coding.